Okay, let's just dive right into this. Welcome to today's Explainer, where we are going to be decoding one of the most extreme, high-heat processes that literally, and I mean literally, pieces our modern world together. You know, if you look around right now at the buildings, the cars, the infrastructure we rely on every single day, you're looking at a world held together by arc welding. We're going to break down exactly how this fascinating process works.
To really wrap our heads around this, we have to start with the visceral reality of what arc welding actually is. It's basically harnessing a continuous electrical spark to melt solid metal. I mean, imagine capturing a sustained bolt of invisible lightning and just using it as a handheld tool. That intense spark, the arc, is what lets a welder turn rigid, rock-solid steel into a molten pool, fusing completely separate pieces together into one continuous structure.
And when I say intense heat, I am absolutely not exaggerating. That electrical arc can reach unbelievable temperatures of up to 6,000 degrees Celsius. Just to put that into perspective for a second, that is roughly the temperature of the surface of the sun. And this mind-blowing localized heat is literally being held right in the palm of a highly trained welder's hand, focused entirely on a joint that might only be a few millimeters wide. It's raw elemental power, but completely controlled.
So here's our agenda for today. First, what is arc welding? Second, the arc welding circuit. Third, pros and cons. And fourth, arc welding applications. Let's get to it.
Starting with Section 1, what is arc welding? Let's define the core process.
So, the absolutely crucial thing to understand here is that this is a fusion process. Unlike just gluing two things together, arc welding fundamentally changes the metal itself. Basically, an electric arc is formed between a charged rod, which we call an electrode, and the metal you're trying to join, the workpiece. The arc heats that metal way past its melting point, so the edges of your two separate pieces of metal, along with a bit of filler material from the electrode, melt together to create a single molten mixture. And when that mixture cools down, you don't just have a patch, you have a brand new, solid joint, a true metallurgical bond.
Moving to Section 2, the arc welding circuit. Let's look at the system mechanics.
Okay, take a look at this neat sketch. This represents the absolute core of today's explainer, the arc welding circuit. You can think of it as a blueprint for controlled lightning. Over on the left, you got the power supply unit, which can be AC or DC. The electricity flows out through the welding lead right into the electrode holder. That's the part the operator grips. The current then travels straight down through the flux-covered electrode. But notice the workpiece at the bottom. It has an earth connection, a welding return line going right back to the power supply. Actually, the only thing stopping this from being a completely closed, continuous loop is that tiny little space right at the work surface, the arc gap. Seeing it laid out like this really highlights the core mechanics and, as we'll see, points directly to some of its biggest advantages.
So let's walk through that flow of electricity step by step. It acts a lot like a basic battery circuit, but with one pretty extreme difference. The power leaves the source, travels down the electrode, and then it literally has to jump across a 3 to 6 millimeter air gap to reach the grounded workpiece. Now, because air naturally resists electricity, pushing that massive current across that tiny gap converts the electrical energy into intense heat. That resistance is exactly what generates that 6,000 degree arc that melts the metal on contact, right before the current safely returns to the ground. That tiny 3 to 6 millimeter jump is really where all the magic happens.
Let's hit Section 3, pros and cons. We'll look at its strengths and its limits.
The sheer advantages are exactly why arc welding is the absolute backbone of structural fabrication. First off, it creates incredibly strong and durable joints that can handle massive amounts of stress. But on a practical level, and we saw this in that neat sketch a moment ago, the equipment is beautifully straightforward. That translates directly to it being highly portable and relatively low cost. You don't need some multi-million-dollar clean room for this. You can drag an arc welding generator out to a muddy construction site or even the middle of an offshore oil rig. It's fast, and it's incredibly versatile, easily welding heavy, thick sheets of steel, iron, and aluminum.
But you know, that major advantage creates kind of a fascinating paradox. While the equipment itself is super accessible, cheap, and really simple to set up, heck, it's even affordable for a home hobbyist, the process absolutely requires a highly skilled operator. There's just no way around it. You can't just pick up an electrode holder and expect to make a joint that's going to safely hold the weight of a bridge. The tools are simple, sure, but the human execution, that has to be flawless.
And this brilliantly illustrates exactly why that operator skill is so crucial. Look at the top here. That is a good weld. See how it's uniform, consistent, beautifully fused? Now look at the others. If the operator travels too fast, the weld ends up thin and weak. If they travel too slow, it builds up into this messy, wide glob.
If the arc is held too short or too long, or if the electrical amperage from the machine is just dialed a bit too high or too low, the joint becomes brittle, full of spatter, and totally structurally compromised. The metal is completely unforgiving. The welder has to perfectly balance speed, distance, and power, all at the exact same time.
Now, beyond human error, there are some hard physical limitations to the process too. Because the heat input is so insanely high, arc welding is honestly pretty terrible for thin sheets of metal. Anything under 2 millimeters thick will just melt away instantly under that arc. That intense heat also brings a real risk of warping the base metal around the heat-affected zone. Also, since it relies on electrical conductivity, you obviously cannot use it to weld plastics. And finally, the melting flux in metal generate hazardous fumes, which means operators always have to work in really well-ventilated areas with proper respiratory gear.
And finally, Section 4, Arc Welding Applications. Let's look at the real-world impact.
Because the real-world impact of arc welding is massive. It is the fundamental construction method used in shipbuilding, literally joining giant plates of steel into watertight hulls that can survive the open ocean. It's used in industrial piping to make sure high-pressure lines never leak. If you drove a car today, large automated plants used arc welding to assemble the metal frame that's protecting you. From the towering structural steel of bridges and stadiums, all the way down to the precise repair of a cracked engine block, arc welding is quite literally the glue of the industrial age.
So, I want to leave you with a final thought to take away from this explainer. The next time you're driving over a massive steel suspension bridge, or maybe sitting in an airplane, or just looking up at a towering skyscraper, ask yourself, how many thousands of controlled lightning strikes, how many 6,000-degree sparks held in the steady hands of skilled workers are currently holding you up? It's this invisible web of immense power that shapes our entire world. Keep that in mind and never stop questioning how the things around you are built.